Think, Learn, Innovate.
Hi everyone. Today our lesson is regarding series solution of ordinary differential equation. So I will take a problem and I will solve the problem step by step, and when you get this kind of similar problems, please follow these methods. Okay? So at first here, I'll say here x equal to 0 is the ordinary point. Now what I will do, I will say let the series solution is given as y equal to sum of n equal to 0 to infinity an x to the power n. This is my series solution. So first I will find out what is the value of it in dy dx. So I will say d of dx of sum of n equal to 0 to infinity an x to the power n, and that gives me sum of n equal to 1 till infinity n an x to the power n minus 1. Similarly, I will find out the double derivative of this equation, d by dx of sum n equal to 1 till infinity n an x to the power n minus 1. That gives me n equal to 2 till infinity n minus 1 an x to the power n minus 2. Now, my next step is to plug these values in your differential equation. So first of all, what I get here, 1 plus x square. And first of all, I will write down this n equal to 2 till infinity n minus 1 an x n minus 2. My next term is x sum of n equal to 1 till infinity an n x n minus 1. And my last term is n equal to 0 till infinity n x to the power n is equal to 0. Now if I multiply the terms, and if I multiply the terms, what I get n equal to 2 till infinity, I will get n minus 1 an x to the power n minus 2. My next term will be sum of n equal to 2 till infinity. I will say n minus 1 an x n minus 2 into x to the power 2. My last, after that, there is another term which is called n equal to 1 till n. I got an, and I got what? X n minus 1 into x to x. And my last term, as in the previous case is given down there, is n equal to 0 till infinity an x to the power n is equal to 0. So after this, I will multiply and I will write down the equation in this format. First of all, it will be sum of n equal to 2 till infinity. I got n minus 1 an x to the power n minus 2. My next term, as there is in a previous case, you have seen that there is an x to the power 2 here. If you see here, there is x to the power 2 and n minus 2, so this 2 will go away, and what I will get? I will get here is n minus 1 and an and x to the power n. Similarly, plus what I get here, n equal to 1 till infinity an, what I get here, n into x to the power n. And last of all, what I get is n equal to 0 till infinity an x to the power n equal to. So after all this, After I got this equation totally, next is I will make this sum like this, n equal to 2 till infinity, n minus 1, an x n minus 2, and I will take sum of this one will be changed. I can start from 0 itself, 0 till infinity, and it will be n, and because it will give you the same value, right? Because if you make n equal to 0, this is 0, n equal to 1, 0. So the total sum value will not change, plus sum of n equal to 0 till infinity, n an x to the power n, and minus sum of n equal to 0 till infinity, an x to the power n equal to 0. Now, I will shift this value to make it from 0 to infinity. So I will shift it by 2, so it will be n plus 2, and this will be equal to n plus 1, and this is my n plus 2, and this will be n, etc. But after this, I will take this one as a common, 0 to infinity common, and I'll place here n minus 1. Then what I will get plus n, I will get minus 1, an x to the power n equal to 0. After this, again I will make this one n equal to 0 to infinity. I got n plus 2, I got here n plus 1, I got an plus 2 and x to the power n, plus sum of n equal to 0 till infinity, and what I get here, n square minus n plus n minus 1 an x to the power n equal to 0. So this and this will go away, and overall equation will be n equal to 0 till infinity, n plus 2, n plus 1, an plus 2, x to the power n, plus sum of n equal to 0 till infinity, n squared minus 1, an x to the power n equal to 0. So I will solve this equation now. I have to solve this equation. And so we'll take common here, sum n equal to 0 till infinity, okay? And I will say n plus 2, and I will say n plus 1, an plus 2, and plus what I got here is n square minus 1. I got what here? I got an, and hold this bracket, hold this together. I got xn equal to 0. So now what I will do, I will take the coefficient of xn and I will make it to 0. So what are the coefficient of xn? So this whole thing is the coefficient of xn. So I will say the coefficient of xn means n plus 2, n plus 1, an plus 2, plus n square minus 1 into an equal to 0. That's your coefficient equal to 0. So from here I can find out the value of n plus 2. What is the value of n plus 2? It's minus n square minus 1 a to the power n divided by what? N plus 1, n plus 2. Where I can write down this one in this format, n minus 1, n plus 1, an divided by n plus 1, n plus 2. Goes away, and I can write down n minus 1, n plus 1 into a. After that, we'll put the values of, different values of n, and I will find out the coefficient. So say let n equal to 0. If I plug n equal to 0, so what I get a2 equal to, what I get? a2 equal to, see, if I plug in the values of n is equal to 0, so I plug in 0 here, I got a2 here, right? And sorry, this is not 1, this is 2. And so what I get here, if I plug 0 here, this is 0, minus minus plus, so I get above plus 1. And this n is 0, so I get 2. And this n is 0, so I get a 0. So a2 equal to 1 by 2 a0. Good. Now I will say n equal to 1. So a equal to 3. And if I plug n equal to 1, I get 6. So I got a3 equal to 0. Now if I plug in n equal to 2, so I got a4 equal to, if I plug in 2 here, 2 minus 1 is minus 1. And I got 2 equal to 4 into 8. And what is my a2? My a2 is 1 by 12, so I get minus 1 by 8 ac. Again, if I plug in n equal to 3, what I get here? a5 equal to, I got plug in values n equal to 3. If I plug in 3 here, I get minus 2. And if I plug 3 here, 5 into a3, where a3 we know is 0, so a5 is also 0. So I got this coefficient out. After I got the coefficient, then I will plug those coefficient into my formula. So let's go and finish it. Now what we'll do the final solution of the series, which we have already calculated. So what we've taken, y equal to sum of, say, n equal to 0 till infinity, and we got an into x to the power a. So that series can be written in the form of x0 plus next one x1 n plus a2 x square plus a3 x to the power 3 plus a4 x to the power 4, and it will keep on going like this. Now, what we'll do, y equal to, we know a0, a1x. What was my a2? My a2 was a0 by 2 into x square, and a3 was 0. And what was the a4? a4 was minus 1 by 8 into a0 x to the power 4 plus dot dot dot. So the solution can be written in the form of a0 plus a0 2x square plus minus 1 a0 by 8 x4 plus dot 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 into a1x. So finally I can write down this equation in this format: a0 1 plus half x square minus 1 by 8 x to the power 4 plus dot 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 dot, and I got plus a1x. So this is the solution of the series. And if you like my video, and please like and share it. I will try to bring more videos of series solution and other mathematical tools. Thank you.